Good morning. Jim Cottrell here. Several of you have suffered through some of these masses before, others haven't. I look after National Foam's business affairs since 1988 in terms of product development and fire department stuff. I formed another company shortly thereafter called Combat Support Products. So I'm a contractor, and so we're not going to make any commercials out of any of this stuff. It's going to be just general information that, with regard to the fluorine-free issues that are about ready to overtake the fire service. In fact, it has overtaken the fire service in 23 states. So what the program is about, and as Paul has asked, and as the fire marshal requested, that we come up and just do a quick overview, a couple hours thereabouts. There's a lot of reading because, truth be known, after I talked to Paul and looked at the program that I had done out in Colorado and elsewhere, I was saying to myself that it needs to change a lot. So I changed it a lot. So it's a lot of writing, and I created a sort of a booklet, as it were. So the handout for this has an index. So the first page on this stuff would be, or before the first page gets there, there'll be an index. So what I'll get to you right now is one of the things that Paul had mentioned was there seems to be a lot of questions about the NFPA Research Foundation report that came out in January of 2020. Full disclosure, I'm part of the Underwriters Laboratory 162 Technical Committee, and I chair the IFSTA, the Foam Training Folks Committee on Foam, and have for many, many years. So I look after the interest of Oklahoma State University on that UL committee, and I'm one of the few guys that are looking after the fire department people. Most of the people on the committee are industrial types or government types, and over the 20 years or so that I've been on that committee, we've discovered that the industry in general really doesn't have a lot of interest in fuels after it leaves the marketing terminal. Their concerns are fuels before they get to the marketing terminal in the pipeline system and in the refining side. My interest has always been, what are you guys doing with the stuff? Because once it leaves the marketing terminal, it's not your daddy's or grandfather's gasoline anymore, because they lace it with ethanol. And now they're lacing it with butane from, say, Thanksgiving until Easter in these latitudes. They're adding butane to gasoline to raise the vapor pressure, to use the term that they use, increased volatility. So the brothers and sisters that are on the job out there, when you're stepping down off the battery box and you got one working and you got people screaming, believe me, this is not the gasoline of yore. This stuff is pretty potent. Its upper and lower explosive limits are a little bit narrower, and its vapor pressures are higher. So my issue has always been with members of the committee and just people in the industry at large, that their big concern is over the top fuel storage tank fires. That's the big deal, large atmospheric fuel storage tanks. Some discussion on spills. Well, your world is all spills. Occasionally you're going to get a fuel storage tank or a marketing terminal, but generally speaking, yours are highway events, transportation events, where life is totally different from the window that I look out of from an engineering perspective. Fire protection engineering is my background, and what you do is combat engineering. And that's it. It's just what the fire service is about. They make a decision right now. We don't have 2 hours to discuss where we're going to set everything up and how this is going to go. When you step out of the cab, something has to happen in a few seconds. And that's what we're going to talk about today. The NFPA Research Foundation discussion, mind you, is a 2020 report. The research was done in 2019. I was part of a Research Foundation report years before that where we reviewed and and looked into friction loss in fire hose, if you remember that report that came out. And I was one of the technical advisors on that. And that report had some issues with it because there was some political issues with not being able to reveal certain manufacturers and things like that. So when the brothers got the report, it's, okay, which hose has this friction loss? It's not a new report. It's kind of a general thing. So we had a general thing here with the same company that did the contractors that did the friction loss thing. So many in industry found flaws in the NFPA contractors' 2019 procedures and conclusions. In fact, at least 2 major refiners and one of the world's largest chemical manufacturers have begun to transition to F3 foams, F3 meaning fluorine free, for fire protection systems and facilities fire fighting and appliances. So since that report has come out, industry has just said, we're moving on. And regardless of what was good or bad about the report, corporate is saying, we're out of it, we're done. We're going to go with the technology that exists now. Regardless of the document's conclusions, the U.S. Navy Research Laboratory have identified at least one F3 foam as equal in performance to mil-spec F24385, which is what the airports are using and all military people are using. In this connection, the Department of DOD has begun replacement of AFFF elsewhere in the world, and F3s are now in use in military systems in the Middle East. So they've already made their mind up that the train's on the tracks, we're moving, and the technology today, let's call it today's date, is way past what my esteemed friends in the committee did back in 2019. This is a moving target. So in defense of anybody that has any argument one way or the other, this is a moving target from a technology perspective. Government is forcing the issue in many cases where they have prevented firefighters from using the good old AFFF that we happen to know is tried and true. So they had to make a transition real fast in certain states. New York is one of them that's in March, has to do it. They have to make the transition out. They had been given a 2-year warning. And that would be one of the local states that might affect what you do or do not do. Connecticut has already done it, and New Hampshire has done it. So I don't know where the Commonwealth of Massachusetts stands on it, but I suspect sooner or later there's going to be some sort of prohibition on uses of firefighting foams with PFAS in it. Third, FAA has a mandate from Department of Transportation. FAA reports to Department of Transportation to transition to an approved F3 fire foam beginning in October of 2021. So the fuse is burned down to the charge right now as far as FAA is concerned. Now FAA says you don't have to. They're just given the authority having jurisdiction the option to transition out of a mil-spec AFFF. Finally, AFFFs versus F3, that would be aqueous film forming foam versus fluorine-free subject, is moot in many states where the use of AFFF PFAS is disallowed. So somebody's got to do something anyway. There's the index that you heard tell of. I'm not going to spend a whole lot of time on that, but if you want to dig into the subject without any commercial speak, this is about as good as I can get it. This is the most current information that I have, and I'm probably one of the better contact people in the nation for this particular stuff for the fire service, because the fire service doesn't have anybody looking after them. The cop shop does, but the fire service don't. And it's the good old boy endorsement network in the fire service. Who's doing what is the question. I rely on Underwriters Laboratory. Have to. Most people do that are in the highly protected risk business. What do I do? What you see here, we do R&D, a lot of R&D lately, fire testing. In fact, Wednesday and Thursday last, we were in New Jersey testing, doing UL tests on fluorine-free firefighting agents, the wetting agents, and the Class B foams, and that got all done at the request of the New Jersey State Police, who are pretty much in charge of driving the bus as far as hazmats are concerned in the state of New Jersey. What they have done is pass the ball over, the finance ball over. They write the checks and let the fire guys do what they have to do, which is a really good relationship, because as you know, the cop shop is much better funded than we are, usually speaking. I do FDNY consulting, a lot of that. I look after all of their things, anything that has to do with foam, and have for more than 10 years, and their marine fleet. I look after systems on the marine fleet, foam systems, that is. We manufacture these kinds of things, these foam trailers, and I do what we call special operations training. I'll go to a oil terminal and take the outside fire department inside an oil terminal. We call it a day behind the fence, to point out where the problems lie for the fire guys, not the engineering guys. And it's a real eye-opener in most cases. And we build these kinds of things, these giant pumps, et cetera, et cetera. So I'm kind of in the business up to my neck. I'm 72. I don't want to go. I don't want to go. For those of you that have already suffered through these things over the years here in the Commonwealth, I'm loving the job. And I try to stay as current as I can. And the people that I contract for are wide open. And they go, whatever he says. So when I write a scope document for a product, in this case, it would be a fluorine-free product, I said it has to pass a UL fire test with blended gasoline, because that's what they're using out there. That's the worst case scenario for the fire service, is blended gasoline that gets released out on a road or whatever, and you got tangled casualties that you have to get out with a lot of gasoline. That's my nightmare scenario. The unignited gasoline makes me really worried. So what we did is we said, or what I had said to our management group is, I want a UL listing for blended gasoline up to 15% ethanol. I want a ethanol listing, gasoline grade ethanol. That would be put a fire test for gasoline grade ethanol, and it needs to happen with fresh and seawater, which was not easy, without fluorine. So the fluorine has always done the heavy lifting. So making this happen without fluorine has been the trick. So with seawater, with fresh water, at a reasonable application rate. UL says the application rate is going to be about 60% greater than AFFF, because with AFFF, the heavy lifting was done by the fluorinated surfactants. You know them, will be knowing them as PFAS. But the PFAS surfactants are the things that made aqueous filming foam film form. Taking the film forming out of it now pretty much took a lot of the bite out of the snake's poison. So we had to come up with another way of doing it. Type 3. A Type 3 application is how you do it. You apply a stream over the top of a storage tank, and the foam plunges into the fuel, or you'll discharge a stream at a spill, at a crash scene, and the foam tends to plunge. Well, with the AFFFs, it didn't care. It would surface and still put the fire out. Fluorine-free, without the fluorine, it'll surface on fire. So be advised, and we're going to get into that in much more depth. The support handout and training handout you can get at my personal website or my other company's website, not National Foam, so they're not supporting this in the least. So combatsupportproducts.com has a training link there, and anything that I've written on the subject and the most up-to-date information, plus all the handouts for this program, are on that training link. In some states, as required by law or administrative mandate, a transition from aqueous film forming foam containing PFAS compounds to a fluorine-free F3 replacement are underway. This program was developed for guidance to firefighters in the pursuit of these changes. To be clear, all aqueous film forming foams contain PFAS, per and polyfluoroalkyl substances, regardless of the manufacturer, regardless of the date of manufacturer, and Class A foam and high expansion foams do not contain PFAS and are not part of this program. So the Class A's and the wetting agents, otherwise known as encapsulators, they never had it. They never had a PFAS problem. So if it says AFFF, be it now or 40 years ago, contains PFAS. Even the newest, latest, cleanest C6 formulations contain PFAS. So there's no way out. When legislation says PFAS, they throw the net out in the water and they've taken all the fish out of the pond instead of maybe 2 suspect fish. And I'm starting to agree with that logic. In other states, the transition is somewhat slower, in some cases driven by fire department health and safety committees, and recently by liability insurers. So fire departments have been getting greetings from their insurers saying if you're using a PFAS product and it ends up in somebody's water table, we ain't paying. So they're starting to subtract that particular bit of protection out of the fire department's environmental part of that policies for what's the word I'm looking for? Help me with the word I'm looking for. Liability, yeah. So the insurance guys, the insurance industry is starting to make the move now. Distribution, fire equipment sales companies have already gotten greetings. Several in New York State, major players in the industry have gotten greetings from their insurance guys say, if you sell it to a fire department, we're going to have a problem. We're going to have to cancel you. So it's happening, and it's happening a little faster than I thought it was going to happen. Federal Aviation Administration and Department of Defense are committed to change as well. FAA timing was set in 2018 for October 2021. Although it appears as of this writing, which was like on the 9th, that the schedule may not be met. We'll be discussing FAA and ARF. Is there anybody here from the aviation community in this class? Probably out in the video. The guys watching this on TV may be from Boston Logan or one of the other metropolitan airports. So I'm going to cover it anyway, in spite of the fact that there may not be anybody in the class that represents aviation. So there was an ARF conference meeting, a working group meeting here a week ago, 10 days ago, and FAA didn't say one way or the other. They didn't commit. The Navy's already made their commitment. So we're going to see where it goes from here, but right now I don't have any guidance for you on where the FAA is going. I'm not sure they even know. Foam standards. These are the standards that a reasonable person would use in terms of safety and survivability for firefighters and their people. Today we will be discussing NFPA 11, air foam agents for Class B fires, UL 162 standard for foam equipment and liquid concentrates, NFPA 403 guidance standard for aircraft rescue firefighting, the U.S. Navy MIL 24385 Foxtrot, currently used by FAA Part 139 airports, and a short briefing on the coming International Civil Aviation Organization, ICAO, foam performance standard, which is a replacement, or which will be a replacement, we're pretty sure, for the mil-spec PRF 24385. So ICAO, the International Civil Aviation Organization, and NFPA 403 are going to have a lot to be said about aviation firefighting going forward. Finally, we will touch on NFPA 18, the standard for water additive agents as they apply to Class B firefighting. NFPA 18 is not NFPA 11. NFPA 11 is the standard that we in the fire protection engineering world rely on. Your fire codes rely on NFPA 11. Your inspectors and your plan review people all rely on NFPA 11. Somehow I got the fire service guys looking at NFPA 18, which doesn't make a whole lot of sense to my mind, to my way of thinking, but they do. NFPA 11 is standard used by building code fire inspectors and fire protection engineers for Class B fire protection systems or manually applied foam streams on a range of hydrocarbon and polar fuels, alcohols. NFPA Type 2 and 3 streams create an air-excluding foam blanket, as described in ANSI ANSI UL 162 test protocol, GFGV. Air-excluding. A blanket. NFPA 18, and I will paint myself with the same brush on this one. NFPA 18, Class AB wetting agents, otherwise known as encapsulators. This standard deals with detergent additives that reduce water surface tension to the extent that water soaks Class A fuels and mixes with simple hydrocarbon fuels. Wetting agents are ANSI UL 162 GOHR tested on heptane, not gasoline, at twice the application rate of AFFFs. Not useful on water miscible fuels, so it says so right on the label, do not use it for alcohol. Or ethanol gasoline blends, and most do not foam. So if you want an air-excluding foam blanket, chances are you're not going to get it from a detergent surfactant. Yes, sir, how can I help?
Is that NovaCool?
It could be. I'm not going to get into that game. Right, right. If you look on the label of the container and it says NFPA 18, UL insists that that label identifies what standard they're using. NFPA 18 is not the NFPA 11 standard. It's not the standard I would use for fire protection engineering. It would be a standard I would use if I was working at a paper and pulp mill and I had a system for soaking and wetting. By all means, I would add that into a system logic. But when it comes to air-excluding foam blanket, it would be NFPA 11. NFPA 1150 deals with foam for Class A fuels, CUSDA, Forest Service 5137. The United States Department of Agriculture, as you were, the U.S. Forest Service reports the USDA. They're under the USDA umbrella. So oftentimes I say USDA Forest Service, so it makes sure everybody knows who's who in the pecking order. And this is the guidance. If you take nothing else from this program, when in doubt about what firefighting agent is appropriate for your fire department, a reasonable person, and that's what you're going to be looked at as a reasonable person, would contact the nearest oil terminal manager and ask what they use to protect their gasoline ethanol loading rack and fuel storage tanks, because they're the ones that have the gasoline ethanol. The pipeline that sends gasoline to their storage tanks has no ethanol in it. I call it vanilla, otherwise known as RBOB or CBOB, without going into any discussion on it. But the stuff that goes into the fuel storage tanks, gasoline-wise, has no ethanol in it. They got to keep ethanol on site. The ethanol may come from a rail or come from a barge. Or in many cases, most cases, in rural spaces, the ethanol comes on a gasoline tanker with a placard 1987. Instead of 1203, it says 1987. And that would be gasoline-grade ethanol, E95 or E98. So this is my guidance, essentially, going backwards on that. Let me go back to that. That's my guidance for people that don't want to get in the middle of the brand discussion. These guys are insisting on a UL-listed agent for their risks. They can pick the one they want that have the appropriate listings, and then it becomes a finance discussion or a performance discussion, depending upon the corporate perspective on performance. A lot of these folks are self-insured, so they really aren't in a crapshoot. And the insurance guys insist on UL. They're not in a crapshoot either, or a Factor Mutual. AFFF, here's a definition, acronym definition: Aqueous Film Forming Foams, airport users. ARAFFF, alcohol-resistant aqueous film forming foam, fire department users. PFAS, per and polyfluoroalkyl substance, the film forming component in AFFF, also called fluorosurfactants. SFFF, not to be confused with AFFF. This one's got me a little bit concerned because NFPA is now starting to use that acronym in the new standard, which tends to throw a little bit of confusion in the game. Synthetic Fluorine Free Foam, not to be confused with Aqueous Film Forming Foam. In the industry, at least the window that I look out of, I use F3, Foxtrot 3. So there's that separation. So then there's an alcohol-resistant version of it. So it would be ARSFFF or ARF3. Third-party certifications. Since most of us in the industry are not in the crapshoot, fire service is, and for some reason, I don't know why, there's nobody looking after them, but the guys that have to write the checks, the insurance guys, they want to see test results, they want to see third-party certifications. So the Navy is one, the U.S. Coast Guard is another, and they're very, very difficult to deal with. The Coast Guard is probably one of the toughest hoops to jump through for those in the manufacturing business. Green Screen certification now is an international third-party environmental certification. If I say I have a fluorine-free agent, who else says it? If it's Jimmy Cottrell foam and I'm out there writing my own literature and say it's fluorine-free, who says it's fluorine-free? Do you have to send it off to be tested or what have you? So there is an organization called Green Screen. It's international. And they are the watchdog in the chemistry world for things that are not cool as far as the environment is concerned. So now they're saying yes or no to PFAS. Yes, the product has PFAS. No, the product doesn't have PFAS. So they're taking one forever chemical, the PFAS. All right, there's no question about it. It's forever. And they're looking at the other chemicals that are also forever chemicals that may not be firefighting chemicals. So they're the watchdog for the forever chemistry stuff that's likely to be in the environment. Foam concentrate is the material in the pail of the drum. Foam solution is proportioned from the pail of the drum. 97 parts water and 3 parts concentrate is a 3% solution. Yes, sir.
On the third-party certification,
yes, sir.
if you saw a UL listing,
yeah,
would that hold up to that green screen or no?
No.
They're not
No. And you know, well, I'm on the record here, so I'm just going to say it. I would like to have UL part of that world, but UL, I'm sure, doesn't want to be in that business. So that's why there's this international group, because UL in the US is considered the last word for a lot of things. That's not necessarily so worldwide. And now we're in a worldwide thing. So now we're starting to look at what they're doing in Dresden and whatever, and some of these other, or Germany with high-tech chemistry countries, and they've created this third-party certification for the industry, as it were. So they would be the UL, if you will, for the industry's environmental side. Finished foam is what comes out of the nozzle, the aerated nozzle, and we make that from the foam solution from the item above. 1 gallon of solution expanded makes 10 gallons of finished foam, which tells me I have a 10-to-1 expansion ratio. Going forward with fluorine-free air foams, you're going to have to aerate now. The only way to get through those UL fire tests now is with an aerated stream. An expanded ratio somewhere in the vicinity from 5 to 10-to-1 expansion. But the fog nozzle that we've been using for years without an aerator has been okay. I've never been a fan of it because all foams are tested with aerators, whether you know it or not. So if they get their UL listing, even back in the AFFF days, it was aerated. We know that if you just put a froth down, it would still work because the aqueous film did the heavy lifting, made you look good. Once fuel soaked into the earth, the aqueous filming is useless. Can't make an aqueous film on dirt and gravel and sand where the fuel is soaked in a foot below it. So to use one of the terms that I'm famous for is mental masturbation. because that's what the fire service is doing with a lot of their AFFFs over the years. This is why there's Mr. Bubble chemical in the AFFF, a lauryl sulfate, sodium lauryl sulfate, or one of those shampoo chemicals, hydrocarbon surfactant, that actually makes bubbles. As the bubbles break down, like beer in a beer glass, it keeps sending out the aqueous film. But it's not going to send it out if you have a crash where the fuel is soaked into the earth. It's not going to do anything for you. So you've got to use the shaving cream part of your AFFF, which tends to disappear very fast. So, application rate. The foam must be applied on a fire faster than the fire consumes the agent. Application rate is the solution applied per square foot of fire. AFFF example, something that you can probably relate to. Apply 1/10 of a gallon of solution per minute per square foot of a hydrocarbon spill fire. Hydrocarbons would be anything that's not alcohol. All right, hydrocarbons are, generally speaking, in the distilled crude family, or organic oils, like vegetable oils and things like that. Hydrocarbon encapsulation, which is a word that's getting thrown around the fire service a lot. In the oil patch, we're not hearing this, but the fire guys are hearing it a lot. Detergent water solutions will mix with oil in some circles known as encapsulation. It is the stuff of NFPA 18 wetting agents and domestic dish detergents. Works when enough detergent solution is mixed with crude distillates. Not a likely winner with gasoline ethanol or when the fuel is soaked in the earth, because with a detergent you got to mix it. And when I do my demonstrations with our wetting agents at the company that I represent, I actually discharge a jet of detergent into a pan that has water and diesel fuel in it, and eventually the fire goes out because I have to mix it. The detergents have pluses and minuses in them, from a chemistry speak, all right? Water and oil are all positive, let's just say, for a chemistry speak. So they're repelling all the time. They will not come together. So when I put a detergent in its midst, then I have to shake it or stir it to get the electrical systems plus to connect to the minus. So that's what the energy does. It realigns the electrical systems so the oil and the water mix together. Without energy, you're not going to make the connections. And this is why I typically use a jet of water through the 2.5 gallon water extinguisher to churn up the fuel. If I don't do that, the fire won't go out. So you're not going to have that luxury in combat, but it looks good for a demonstration. Hot road spill. This is what scares me. This is what has my interest for you in terms of safety and survivability. Also out in the fleet with Navy guys on a flight line or in aviation. Hot road spill. Fuel is heated as it runs across the hot pavement. Can take most fuels to their or past their flash point on contact. Hot spills have increased vapor pressure, otherwise known as volatility, and are a major concern for rescuers dealing with entrapments where liquid fuels are present. So if the fuel just ran across the 150-degree road surface in these latitudes in the summer, which is perfectly probable, the diesel fuel now is 30 degrees or 20 degrees hotter than its flash point. Its vapors will behave identical to gasoline vapors at that point. If it pools after it got hot, I would treat it like gasoline. The good news for us in combat usually, particularly in the rural spaces or on interstate highways that still have median strips, and they're rapidly disappearing, once the diesel fuel is soaked into the earth, the temperature of the diesel fuel takes on the temperature of the earth real quick. So diesel fuel has a flash point, a temperature where you can match light it or that'll ignite with a spark at about 130 F. So once it soaks into the ground, it kind of self-safes itself. Gasoline has a flash point of about 50 below zero. So whether it's soaked into the ground or not, it doesn't make any difference. But the diesel tends to safe itself when it soaks into the ground, or if it runs across cold water. In fact, here at school, we do these flammable, really it's combustible liquid training with diesel fuel or home fuel oil or kerosene, and just spray water into it until the temperature of the kerosene gets to the temperature of the water, and it goes out. We're lowering its flash point with the introduction of water streams. So once we get it much below its flash point, it goes away. Fire goes out. Gasoline, you're never going to make that happen. Never going to make it happen. Application types. Type 2 applications include those that one would use on foam destructive fuels such as polar solvents and some acids. Use a bank-in backsplash off the side of wreckage or roll-on using nozzle velocity to push foam onto a fuel spill or a gas or a fire as gently as possible. I've always been a fan of that. Even though I know that the AFFFs could plunge into it and come up and still put the fire out, gentle application on alcohols is a must. You cannot plunge your alcohol-resistant AFFFs into alcohols. It's got to hit the side of a wreckage, slide down, and creep across the fuel, or use nozzle velocity, as you're seeing in this shot, pushing the foam onto the fuel spill. Hold vapors down. When do you replace it? When you stop smelling, well, when you smell gasoline, put it on again. I mean, I know I got a $10,000 gas detector there, but if your troops are smelling gasoline while they're doing whatever it is they're doing, chances are you need to put a cap on it. Or use your instruments to tell you whether you got hot fuel. Type 3 applications include those that one would use on a fuel storage tank fire where over-the-top application is required, or where spill fires are engaged with plunging foam streams from hand lines, or these types of applications. Here we are in Chesapeake, Virginia. They do this drill very frequently. In fact, that's where I'm going when I leave here. I'm going to be there tomorrow at noon when we're going to do their drill. They are not in a crapshoot in Chesapeake. They're part of the military world there. So that's a type 3 application, or discharging it into the fuel spill. You can't do type 3 hard discharge now with fluorine-free foams. Again, part of that scope document that you heard tell of earlier, that was one of the things that I had in the scope document that I didn't think I'd get it, was a type 3 UL listing. We did. So we got that UL type 3 listing for that particular product that I'd asked for. Foam residence time. I'm trying to replace the term quarter life in our lexicon with residence time. As soon as I say residence time, you know what we're talking about. Back when I said quarter life, my assumption was you knew what we were talking about. Quarter life is who cares? Residence time, you get it right away. How long is the foam going to hold vapor down? Is the question. The time it takes to drain 25% of the finished foam weight goes to how long fire foams hold scene security at spills or recently extinguished Class B fires. This was one in Pompano Beach, Florida, where the guy lost almost 7,000 gallons of gasoline in the ditch along the interstate here. He had just left Port Everglades, where they fill their fuel tanks. He got upset, wound up in the ditch, lost most of his load, and he was hanging from his harness, left side, top side, and the batteries were swinging when the first responders got there. They were walking ankle deep in gasoline when they were reconnoitering. And he's screaming. So they put a blanket of foam down, and then they started the tools and got the guy out, and he was driving 2 weeks later. This is a high pucker event for anybody who's involved in that thing. The battalion chief that was in charge of this thing is a former Yankee. Of course, most fire chiefs in Florida were former Yankees. And he and I have been friends for years, and he said, "You're going to love these shots because this is the real deal. This is vapor suppression." Experience shows, now this is more statistical stuff that I've had to do. In fact, I had to do it for Colorado when they passed their law. And I'm saying to people that are off the record with me in conversation that are talking to legislators, I'm saying, wait a minute. These guys don't put PFAS into the drinking water when they're fighting fire. The environmental impact is when they're holding scene security. They could be doing this for hours. Putting the fire out is a 15-minute exercise. With gasoline, if you don't do something about it, it's going to be gone pretty quick anyway. It burns out about 1/8 of an inch a minute. So by the time all the king's horses and all the king's men and women get there to do something about it, most of the violence is over. Unless it's pooled, or worse, soaked into the ground. Once it soaks into the ground, you have a catalytic fire. No more surface fire. Slows it way down. But the fire is no less hot. So fuel soaked into the earth become catalytic, capillary fire. A candle lifts the wax up the wick from the heat. That's a catalytic or capillary fire. You roger that. So when fuel soaks into the earth and it ignites, that's the fire you have. Fire protection engineering, be damned, there's nobody that does that research. I worry about it. Did I just blow somebody's ears away when I hit that microphone? Anyway, therefore it makes sense that residence time, quarter life, be considered by fire service supply chain officials when selecting F3 fluorine-free foam products. So about 80% of foam concentrate that's sold for Class B fires is used for babysitting spills or unignited events, because there's still fuel. If it's been burning for an hour, chances are there's not much fuel. Chances are you got 18 200-pound rubber tires burning and a whole lot of fiberglass that still keeps that black stain in the sky. Chances are there's not a whole lot of fuel there left anymore, other than what may be in the trough of the tanker truck that will burn down to its liquid level. So what the fire service is looking for is a stout brew for vapor suppression. But you want a light beer for fighting a flammable liquid spill fire. You want a light, frothy AFFF. Back in the day, or still today, you have that option. The AFFF as a froth puts the fire out pretty much on contact. If there's no fire, there is no application rate. Just maintain a good 3, if you can, 3 or 4 inch blanket of foam. Gentlemen, ladies, it's water weight in the foam blanket that holds vapors down, not the bubbles. As the water drains out of the foam, lividity or gravity takes it out. The faster it takes it out, the lighter the foam gets, and eventually vapor escapes and finds their way to a source of ignition, and then the foam blanket lights up as well. So we're looking for a stout brew for these kinds of work, and a light beer for the spills on the highway or the flight line. How you can manage these things now with the fluorine-free is with the proper aeration. If you go to a lower expansion ratio, you're going to have a much more fluid foam that'll probably knock fire down, but it won't hold things down because it doesn't have enough water weight in it to hold the vapor pressure. At that point, I'd start to ratchet up my expansion ratio to upwards of 7 to 10 to 1. That is what's going to hold the most water weight while I'm waiting to clear the scene, or while you're waiting to disentangle casualties or recover cadavers or do whatever it is we do, because that don't happen in the oil patch. And it has to happen with you as soon as you step off the damn battery box. You have seconds to make this call. It doesn't happen that way elsewhere in the world that I live in. And that's why I'm so passionate, as you can tell, about what happens to the fire guys, because nobody's really looking after us. Shelf life. Foam concentrates do not have a use-by date. The container dates are UL birth dates and lot information, stored as if for house paint, prevent evaporation. Metal containers are the things that had shelf life. When I broke into the fire service in 1969, there were metal containers. They had shelf life. I remember lifting the handle up and the damn thing would come apart and it'd be all stinky, gooey stuff down in the basement of the firehouse. All right? I'm seeing some head shaking, so somebody is almost as old as I am. But the protein foam containers, metal containers, had the shelf life. Once we transitioned to a poly, no more shelf life. Even as long as the cap is on it, snug. If there's no cap on it, it evaporates. That's all we're worried about, is the evaporation of the foam concentrate. This business about, and I'm hearing this from instructors all over the country, well, if air gets on the foam, no. We're trying to prevent it from evaporating. So you store it if it were latex paint. You put the cap on the latex paint pail properly, 5 years later, it's still good. Use that logic, or use that logic when you're instructing or talking to your troops. Make sure that the container has the cap back on it and put it away. So half a tank or half a pail of firefighting foam, regardless of brand, will be fine if you look at life that way. Foam sealer oil. Mineral oil was floated on top of AFFF because the mineral oil would not mix with the AFFF. Remember, the fluorine was preventing it from mixing. So we could get away with that to prevent evaporation in foam concentrate storage tanks that didn't have factory packaging if it was decanted into another tank. So what we would say is go ahead and put 2 inches of sealer oil on it, otherwise known as mineral oil, and you're good to go. But this would have to be a stationary tank. It can't be an engine's foam tank because it sloshes around. Plus, mineral oil happens to be a combustible liquid too, so when you get down to the mineral oil, it could be embarrassing. So no mineral oil on mobile apparatus, particularly marine, because they're really sloshing around. In those cases, I want to keep the tank topped off as much as I can to prevent as much airspace from churning up with the foam and making a whipped cream that will proportion lean. So this is why I need for y'all to keep your tanks topped off. Has nothing to do with our commercial interest, has to do with how fit the foam would be, because as it sloshes around in a quarter of a tank, you got all that airspace in there and it's going to froth up. So when you set your meter at 3%, you're going to get 3% of the froth, not 3% of the concentrate. So it's important that B-Shift refills the tank when they get back. F3s can't use the wetting age, the mineral oil, because they're detergents. So it's not even an option with the F3s. So stay clear of mineral oil sealers when you make the transition to fluorine-free air foams. Pressure vacuum vent. Foam storage tanks of all descriptions must be fitted with pressure vacuum vents. Such vents prevent evaporation and will allow replacement air as the tank is drawn down. So fluorine-free foams, these rules apply to those as well. All your rigs have a pressure and vacuum vent on them. Whether they're in good mechanical condition, I can't vouch for, but if they're doing their job, the foam in the tank will be fine, regardless of how old it is. But you're going to have a problem with the foam froth trapped into the pressure and vacuum vent if you don't keep the tank sealed. The alcohol-resistant chemical that's in firefighting foam is sugar, xanthan, X-A-N-T-H-A-N, xanthan gum. Look on the back of your salad dressing container. That's what it is. It just so happens that when it detects alcohol, it kind of polymerizes and does what it's supposed to do. That's the stuff that gets caught in vents. And it dries, sort of like a loogie on your shirt, all right? It's wet when it started and it's dried and you can't even peel your pocket open, all right? The vent works the same way, all right? Pressure vacuum vents will get stuck from that sugar. What will change when you make the move to F3 foams? What will it affect? That's me when I was a kid. F3 foam, and when they had color pictures in those days too, smartass. I know you're going to say something. Anyway, what's going to change? Application rates will increase due to the withdrawal of PFAS fluorosurfactants. F3 wetting agents have no such guidance. So wetting agents don't even have these guidances. Per UL 162, when using synthetic fluorine-free foams on hydrocarbon spill fires compared to AFFF, the rate increases from 0.10 gallons per minute per square foot to 0.16. And any way of looking at math, that's 60%. So that's how much of a hit we're taking in combat when we get rid of the fluorine. We're going to have to increase our application rates. As long as you know it going into it, I'm good. But you can't use your old tenth of a gallon per minute mentality, which people don't anyway. But let me just put this into some sort of, excuse me, common sense. Let's say you got a 100-gallon-a-minute foam eductor. The person that invented 95 needs to be found and shot. All right? 100 gallon a minute, I can do that math all day. At 3%, we'll drink 3 gallons of concentrate a minute. Does that make sense? Multiply 100. That's the number on the side of the 100 gallon a minute, times 10. Now I'm doing the algebra for you. It'll handle a 1,000 square foot fire. The turret on the crash truck, 1,000 gallon a minute turret, 10,000 square feet. The 125 gallon a minute eductor, which is probably more popular than the 95, will do 1,250 square feet. You roger that? You getting the math? You don't have to do a whole lot of thinking on this. I'm just giving you what I call the rule of 10. So the Cub Scout can get it. If you tell them, they'll remember it. Now you're going to have to go to the rule of 4. I'll do that algebra for you. So you take the same 100 gallon minute eductor, multiply times 4. How many square feet will it handle? 400. If it's alcohol, half that amount. If you have alcohol-resistant fluorine-free foam. The alcohol-resistant foams really didn't suffer when we took the fluorine out, because the fluorine only works on hydrocarbons. If it's alcohol, we don't care if there's fluorine in it or not. We're worrying about now the sugar polymer that holds the vapor down. That's why we used to call them smart foams, or I still call them smart foams. They know what they're going on. Unignited spills have no application rates. Maintain a 3 or 4 inch foam blanket. That is the real good news. It's always been. I have management folks that do their math and they're doing their consideration for spills on highways and whatever, using the rule of 10. That's wonderful for ignited events. Mind you, the ignited event has a fuse on it. It's going to be gone pretty soon. Spill fires tend to burn pretty darn fast. The definition of a spill fire, which isn't on the show here, but the definition in our world is 1 inch or less of fuel. Fuel in depth is like a fuel storage tank. So we know a spill fire will be gone very soon if you don't do anything about it. And this is why the application rates were so low for spill fires. With over-the-top storage tank fires, the AFFF still had a 0.16, same as the fluorinated stuff, the fluorine-free stuff. The only place where you're likely to use 60% more is on a spill fire. If you're going over the top onto a large storage tank fire, you're going to have to go at 0.16, even with your AFFF. C, AFFF's residence time, quarter life, will increase dramatically over AFFF from minutes to hours. If there's any good news, or there's a silver lining in all of this, your air foams, regardless of manufacturer, that get through the UL hoops that you want them to get through, blended gasolines and those kinds of things, ethanol. The good news is they went to hours. Part of my scope document said it needed to last at least an hour because the stuff we were replacing was half hour on a good day. And saying, can you bump up my quarter life? Because the oil guys don't care about the quarter life too much. So when I asked chemistry, engineering, and product management, can we get an hour? They said, well, here's the good news. By taking the fluorine out, we're giving you 2 hours. Unintended consequence. So now the residence time is hours instead of minutes. Now what does this mean for environmental impact? Much improved. More to the point, how much water you need to carry on the rig. If I put foam down and it lasts for 2 hours, I don't have to continuously apply it every 15 minutes. And there's where the environmental impact came from, having to keep reapplying to keep scene security. So the fluorine-free guys went from minutes to hours. Proportioning accuracy. This is maybe a two-edged sword. AFFF was very forgiving. I check proportioning accuracy of onboard systems and foam adductors when you make the transition to fluorine-free. Viscosities vary greatly with F3 foams and will surely affect proportioning should viscosities be more than 2,500 centipoise. Water is 0. Maybe it's 1. I forgot. Anyway, that said, now you got an idea. When we mix that sugar in, the xanthan gum is what makes it thicker and thicker and thicker. Normally, it's almost the viscosity of water. It's the alcohol-resistant chemical that makes it thick and gooey and snotty, as it were. Okay? By adjusting all of that, we can make it thick or thin. Some formulations require a lot. This is all chemistry. This has nothing to do with me. I just set the scope document up. I just say what I want it to be. They're the ones that have to figure it out. We have discovered that anything above 2,500 centipoise, and that's on the document of any mainstream foam manufacturer. That document will show viscosity at temperatures 22 F, 70 degrees Fahrenheit. As temperature goes up and down, that viscosity moves. So you'll see in parentheses next to the number, plus minus 300 or something, because we can't be sure of the temperature at which the stuff is done. But 2,500 centipoise is the drop dead point to my way of thinking from a systems perspective. If you have a foam system on your engine that just uses like a car wash pump, a piston pump, a very inexpensive foam system, works wonderfully with Class A foams because its viscosity is like water. Works wonderfully with AFFF because its viscosity is close to water. So this is how I can get away with a Jimmy Cottrell foam system by saying it's an AB foam system. Well, as soon as you put alcohol-resistant foam in the tank, all bets are off. The thickest stuff in the world, from my perspective back in the day, and still today almost, was the universal gold stuff, which is very popular in this part of the world. And I had to deal with it. Foam adductors don't care. But the foam systems that have no suction energy, we do have a problem. And this is what's going on with those. And I'm going to make it real simple. Ketchup in a bottle, thick and gooey. And if you take the cap off of it, nothing happens. Give it a little squeeze, whoosh, it's on a hamburger. In fact, maybe way too much on a hamburger. So they drill a little hole in the cap, and now you can squirt it on. And when the ketchup hits the hamburger, back to goo again. These are called non-Newtonian fluids. When they move, their viscosity changes. The faster they move, the thinner they get. And this is why you could use a foam adductor. This is why you could use a gear pump. Things that pump concentrate that have positive suction on their suction side to pull the foam out of the tank. If you don't have it pulling the foam, chances are you're going to get intermittent foam, and I'll get a call and say, well, you know, your foam sucks or whatever, we're making intermittent foam, or your foam adductor don't work, or our fleet management says the foam is gelled up. Well, Chief, that's how you bought it. All right, and if you bought something that's 2,500 or higher centipoise, chances are it ain't working. And they're not going to get through your filter strainers. The more expensive systems that use different technology, like foam adductors, which are simple yet, I mean, there's no batteries, there's no computers. FDNY just threw them all systems out there, just using adductors now. And they're saying, we know they work, because there's no batteries, there's no electronics. Just make 200 PSI and it works, with certain rules. So be careful of, because there's a lot of good, really good fluorine-free, alcohol-resistant foam products out there, several of them. But a couple of them kind of self-disqualify because their viscosity is so high that I probably wouldn't be able to use it with a foam adductor. So the question is how do I get it through the UL test? We batch mix it and then send it through the UL test. Rather than using a foam proportioner. Okay, I'm going to go through this, and then we're going to take a 10-minute break. Update application training. Now you're going to have to update your training. There's a picture out of the AFFF foam training manual that, if you've ever seen that manual, that's one of the pictures. Anyway, update application training. Aerate F3 foams for best fire suppression result and maximize resident time. Finished foam quality is critical, since fluorinated surfactants are not likely there to do the heavy lifting. F3 foams are UL tested and listed as air-rated finished products at 5 to 10 to 1 expansion. Master stream nozzles on foam trailers and tenders, bigger, will need aerators. Always did need aerators if you were going after alcohol. Somehow somebody didn't tell you all that in the Commonwealth, because I see a whole lot of foam trailers without aerators on their master stream device. So as long as they're dealing with hydrocarbons, they were good to go. So we're now making aerators for that old brass nozzle that is on most of your trailers and Connecticut's trailers. They've had me engineer a clamp-on thing to make their systems live with the fluorine-free. Connecticut's making the transition. They're done. Not done doing it. They're in trouble trying to figure out what's the definition of clean. What's the definition of clean? How many parts per million or per billion, and the rinse water and all the rest of it. So they haven't started filling the foam trailers yet until we get the definition of what clean is. But they are making all the changes to the firefighting equipment on them to accommodate the fluorine-free foams. Now, here's something my management group is not likely to be happy with, but I'm going to tell you anyway. When somebody orders a drum of training foam, it's going to cost you to get it to Springfield, Massachusetts, $753.50. Big freight bill. We're shipping you a lot of water. Probably about 50 gallons of water. The rest of this stuff is super concentrated, Mr. Bubble. So this is what I tell people to do, is take the super concentrated stuff, which is USDA approved already, because it's US Forest Service approved. So as far as they're concerned, it's good to do. Bambi can drink out of the pond after we go over it with a helicopter. So I take a 50-gallon drum of water, put the water in the drum first, and then put in 5 gallons of concentrate on top of it. In about 10 minutes, it's in solution. It'll disperse in the water column without you having to use a paddle or roll it around or anything. And I can do this for $3 and change. So it's costing you a bloody fortune to ship the water from North Carolina or Indiana or wherever the foam factories are. Pennsylvania don't have foam factories anymore. And the freight costs are killers. So what I do with our larger customers of mine, where I do a lot of big training with big equipment, is I just fill a tote up with water, or 3/4 of the way with water, and put in 1 or 2 5-gallon pails of this stuff and train our brains out. And it's almost free, if all things considered, and 0 environmental impact. So there's a little tip for you. Let's take the break now. Let's return at 20 minutes past the hour. That will be 10 minutes. Thank you very much for your attention. All right. Thanks for being prompt on the return. Exactly 10 minutes. For those of you that are watching online, hopefully you're back with us. We're going to switch out of that training. Are there any questions? This is a good time to field a couple of questions. Good. The folks online, write them down or do whatever. At the end of the program, if you want to tune in with questions, I'll be here for a while. If not, you can just email me your questions. And Paul will make sure that everybody has my email, because I didn't even put that on the slideshow. The training foam is, you can make it yourself without having any environmental impact. I think I would let this go through the Nick sniff test first before you go ahead and jump on it. But I've done it in Massachusetts before. So here's something else that has to happen, or should happen to my way of thinking. Public's right to know. It's a good idea to inform the public of your changes to a non-fluorinated firefighting agent, as the old AFFF and the new F3s present the same. Remember, Class A foam and high-X foams do not contain PFAS. See the PIO, Public Information Officer, piece I published on my website. It's also part of this program's handout. So if you have a printed handout, it's that whole white paper that I did is there. And that's what it would look like. Next, cleaning and decontaminating apparatus, marine systems, and foam trailer tanks. The how-tos are included in this handout, which is also part of your handout. Those of you that have an electronic copy of this presentation, it's all there. All you got to do is print it out. Now, this is, again, to my way of thinking, my opinion about how to clean a foam tank, because nothing's really changed over the years in that regard. But I can say this. The alcohol-resistant stuff tends to be a pain in the butt. Because remember the sugar that I told you was in it that made it thick and gooey? Well, when you drain the tank, that stuff sticks to the interior of the tank. So getting it all is could be a challenge. How I've learned to deal with it with our own systems and when I do my own stuff at our shop is I use warm or hot water and let it sit in the tank for a half hour to an hour, and it helps dissolve that sugar so it ends up in the water column. So if you have that luxury of using warm water, and if you don't have that luxury, figure it out, because you'll be flushing until the cows come home if you're not using warm water. Now, how do you know that you are flushed? When the flush water stops frothing, that means the Mr. Bubble chemical is gone, along with it and everything else that was carried with it. And that's how I've done it for years. I tell firefighters to just discharge your hose line, shut off your foam system, and just keep discharging until the water that's coming out of the nozzle runs clear. You know, on the ground. You're not seeing any frothing anymore. It's clean. You don't have to do it for a half hour. Just discharge until the bubbles are gone. Kind of a common sense thing. AFFF and alcohol-resistant AFFF concentrates and flush water should be incinerated. That right now is the state of the art. There are some emerging technologies in this area that may make disposal somewhat less expensive, and I can't be sure of that. But check with State DEP for latest guidance. I thought Nick was going to be with us today, but he got deployed, so he and I have been over the years kind of connected as far as technical advice. So between Nick and me and Connecticut and a couple other states, without my commercial interest being served, I've kind of helped out the family, as it were. I can say this. I was contacted by a company that claims to have emerging technologies, and I sniffed it around a little bit, and it seems legit. You know how they deal with wastewater in your sewage treatment plants with a flocking thing, and the flock carries out the unwanted nastiness? Well, this company seems to have invented or knows of a way of a flocking agent that's sensitive to PFAS. I think it's real. So I'm not going to make any commercials for it, but it sounds promising to me. What is it going to cost? I have no idea what it costs. But I can tell you they're claiming that when they're done with a 500-gallon foam tank, they're going to have a cow patty size dried up chunk of PFAS that can do landfill or some other way of disposing. That's just hearsay at this point, but I would be remiss if I didn't tell you where I was in terms of my latest information. And they came to me at the FDIC with all kinds of sales promotion stuff, and I said, I'm coming here and there ain't going to be no sales promotion stuff. So I just said I'd mention the technology. I'll get Nick and Paul the information, and You guys can find out if it's real or not. The representative for that company lives in New Hampshire, and the other person lives in California. So that's enough said there. Foam quality. Finished foam expansion and drainage quarter life is critical in terms of foam application success at ignited and more likely unignited events. See Fire Department nozzle foam quality handout. In August, Orange County, actually it was Orlando, City of Orlando Fire Department, their hazmat chief there, and I got into, as you can imagine, I get a lot of conversations from guys like that. And they are in the process of making the transition into fluorine-free. And his question was, what about, you say it's got to be aerated, what do we got to do? I said, well, you can use what you got. Akron, Elkhart, TFT, if, they all make a foam aerator attachment for your structural nozzle. What I'm trying to do is make sure that you can get at least 5 to 7 to 10 to 1 expansion, because that's how we test at UL. So when someone asks the question, if something hits the fan, did you use the product in accordance with its UL listing? The answer is yes. If you didn't, then you could be in a hot seat, because the UL listing is predicated on foam quality. So if you use a kid's bubble wand, chances are it ain't going to work. So there's the deal. So I created a document that separated the engineering speak out of common sense stuff, and there it is. So this would be a document that you have as your handout now. I did it in August. Fire Department foam nozzle, finished foam quality. We're looking down the barrel of this fluorine-free gun, so I'm wanting to tune you up on foam quality. So this would be my opinion, not National Foams or Ansels or ChemGuards or whomever. I look after a lot of people's stuff out there as a contractor. This is Jimmy Cottrell's opinion and my company's opinion on this stuff. And I pretty well got a good reputation on it. So when you look at this stuff, it's going to make a lot of sense. A little history. This was a job that one of my first fires that I was at back in, I don't know, it was early. No, it wasn't my first fire. It was my first big, scary fire. And this was in Newark, New Jersey, at a Texaco terminal, where they overflowed the tank. It blew up, killed some people, and this was the next day. So things went bad that day. We never did put the fire out, just let it burn out completely, and there was 3 or 4 tanks involved. Once it got the headway on us, we just let her go. And all the experts came out and said, yeah, no, they didn't say that. They said, let's buy a lot of foam and put a lot of foam on it. And Chief Caulfield, who was the boss in those days in Newark, said, no, let's back off. So the history. How we made foam in the 1900s to the 1930s, we put aluminum sulfate and sodium bicarbonate and licorice stabilizer mixed into a hopper, was introduced to a hose that discharged carbon dioxide froth capable of smothering pooled hydrocarbon fires. They poured A and B into A and B hopper. Then in the 20s, there was a combination version of it made. In the 1930s to the 1960s, Navy bean soup protein was used. They'd hydrolyze hoof and horn meal, ground up hoof and horn, and during the war, they were in such short supply of hoof and horn that they actually used soybeans. So the foam that they made was a hydrolyzed protein that came from soybeans or hoof and horn animals. So that's what the pictures on the right are, hoof and horn meal. And National Foam made a liquid here in the States. It was the only game in town, actually in the world in those days. And the Brits had Angus, who had borrowed the technology. The rest of our competition in combat didn't have this technology. And this is why, frankly, a lot of the Pacific Fleet survived when the other guys didn't. The damage control parties used this Navy bean soup, as it were, and they used aerating foam nozzles and had to apply it gently. And if you discharge it in the air and wanted to rain down, if you're out on a weather deck, the wind blew it away. So then you had to put it on and roll it on, or hit fuselage or hit something and let it roll on the fuel. Those days are back. Because these proteins had a magnetic attraction for the hydrocarbons. So as soon as you plunged them in, they'd come up on fire. They were like sponges. Much, much worse than the current technology, but that was the case. So during World War II, they put a lot of fires out with them, and then when the gorilla got out of its cage on the Oriskany in 1966, and then in Vietnam, the USS Forrestal, they were still using protein. The protein foams had, the AFFFs have yet, this was in 1967, the invention was in 1960, all right? The first Navy specification was in 1963. But in those days, that's how long anything took to get out in the fleet. So in the meantime, you see what we got. Then AFFF started to get out into the fleet, and things changed very rapidly because it was a game changer. Now I could use a damage control station water spray nozzle. In those days, they were using an SG-60, if you recall that Rockwood kind of nozzle. And then they changed over to a water spray periphery nozzle. With AFFF, there was so much Mr. Bubble jammed into this stuff, and so much fluorosurfactant jammed in, that they could use a non-aerating damage control station nozzle, and it frothed up to beat the band just from its excitement going through the air. At about 50 psi nozzle pressure, we're at 88 feet per second. So a lot of the foam bubbles survive the shear. Once we get up to about 100 psi, too much shear, and a lot of the bubbles don't survive. So the aerator had to be invented for that. So here we are with fluorine. The chemical element of atomic number 9, a poisonous pale yellow gas of the halogen series. It's the most reactive and sturdy of all the elements. You can't kill it. You can't break it. It's forever. In 1952, the 3M companies Patsy Sherman and Sam Smith co-invented a long-chain electrochemically produced fluorosurfactant, you know them as PFAS, which helped create products among other things like Scotchgard. Fluorosurfactants, PFAS, are commonly used in fire foams, dyes, inks, latex, paint, food contact paper, fabric coatings, and high-temperature nonstick cookware. Aqueous Film Forming Foam, AFFFs, became a true game changer in liquid fuel firefighting world sometime in the 60s, when the U.S. Navy researchers Tuve and Carhart discovered that one of the 3M company's electrochemical compounds allowed a microscopic film of water to skim across liquid hydrocarbon fuels. They had true spill fires. If I had a spill overboard, close aboard, I have fuel on top of the water, so this film forming stuff worked great there too. You roger that. So from a combat perspective out in the fleet, this was like somebody sent them some wonderful stuff. And they didn't have to have specialized training. Wave it through the air, and when it came down on contact, fires started going out. The first military specification appeared in 1963 through 65 before it even got in the fleet.
This video clip represents an aqueous film spreading across heptane. Heptane is a test fuel used by U.S. Navy Mill 24385 and underwriters' laboratories.
So here the foam blanket acts as a reservoir for aqueous film release. It releases its water film over time, there, much as beer head drains its beer in a glass. So as soon as I put that dollop of foam on that Petri dish that has heptane, heptane is our test fuel. Heptane is a day on the beach compared to gasoline, by the way. Heptane has a flash point of 25 degrees. Gasoline is 50 below zero. So heptane, when it's burning, however, takes on the fire characteristics of pretty much all known hydrocarbons, with the exception of gasoline blended with ethanol, which is why I get so emotional over this, because you're the only ones that have to deal with the gasoline with ethanol. The guys in the oil patch don't. Nor do the Navy. So here the foam blanket acts as a reservoir for the aqueous film. So as the foam blanket drains down, cheap beer and light beer drains down, it keeps sending out the aqueous film. We know this is healing. The foam blanket is healing. So as you traipse through it or pull hose lines through it, as it keeps draining down, it keeps healing in behind you. You roger that? So these are healing foams. The term healing was invented there. The 3M company became the 900-pound gorilla like overnight for firefighting, because their electrochemical process was patented. That was the process that made the surfactants. If you wanted to be in the business, you needed to buy your backbone chemistry from 3M. My company said, no, we're not going to buy it from the Scotch tape guy. We're going to go find somebody that makes it without doing it electrochemically. So they figured that out, and they found it out. It was a company in Pearl River, New York, called Sheba. And they made the surfactants that did the same thing, unbeknownst to us at National Foam at the time. Nobody cared about environmental stuff in those days. And when we couldn't read much more than parts per million when we were doing, I remember when I was doing fire investigations when I was a kid, you know, the gas chromatograph was the big thing for us. And depending upon how long the tube was in there, it was the thing that determined, you know, how far I could drill down into a particular specimen that I sent out to the lab. Well, now that technology is amazing. Now, back in those days, I could read parts per million, and everybody thought that was a big deal. This was in the 70s. I did the Stover's Hotel fire. That's one of my claims to fame there. And the brand new alcohol, tobacco, and firearms guys said that they had a lab that they could pull hydrocarbons out of concrete. Turns out that we pinned our hopes on a lot of that in court, and nah, it wasn't the case. But we can say that the surfactants that were used in any of that stuff, like a kid's crayon, I mean, we'll be able to see that now. Anything in that range. So finding the fluorosurfactants is pretty easy now with high-tech gas chromatograph type of research. And it's getting better. So here's the Jim Cottrell thing. Even though we do have materials that are not biopersistent anymore, that would be manufactured with a process called a telomere process rather than electrochemical process. The telomere process, according to science guys, it's not biopersistent. Where the electrochemical stuff was biopersistent and legacy foams, and this is why Nick asked for y'all to give your foam to him that was manufactured before 2003. After 2002, the Fed said, can't have it anymore. Not in the country, can't make it, can't use it, can't import it, can't export it. So the alternative chemistry started in the early 2000s. That was not biopersistent, but certainly is environmentally persistent. Now, the window that I look out of is those were the days when we could read parts per billion. What happens 10 years from now when someone says that this stuff is okay, now I'm reading parts per trillion, and whoops, there it is again. So that's just the perspective that I look out at. And so if we have the technology to do it without the fluorine, I'm in. I hate it, but I'm in, because I know how good the AFFFs were. Fluoroprotein foam. In the 1960s, the addition of fluorosurfactants to protein foam was a game changer in the industrial fire protection world. Protein foams, now called fluoroprotein foams, became a very sturdy, highly heat and fuel-resistant systems foam. Added fluorosurfactants allowed plunging, over-the-top tank firefighting, type 3. Type 3 there was no such thing as type 3 until the fluorosurfactants were added to firefighting foams. You could add fluorosurfactants to Mr. Bubble, synthetic, or you could add fluorosurfactants to proteins, fluoroprotein. This changed everything. Now it allowed subsurface injection because the oleophobic nature of the fluorosurfactants allowed the foam to rise through the fuel column, surface, and put the fire out. With regular protein foam, didn't happen. It came up on fire. There's a lot of systems out there, particularly older systems. For those of you that do in-service inspections, I don't know what the Commonwealth of Massachusetts does for fuel storage tank inspections, etc. But I can tell you this, there's a lot of subsurface injection systems out there that are using AFFF or fluoroprotein. They transitioned into the AFFF probably in the mid-1980s, early 1990s from the fluoroprotein as improvements in AFFF technology continued to move. Fluorine compounds, PFAS, and AFFF is so oil resistant that it can be injected, I already said that, but not with fluorine-free foams. This is going to be a problem. I'm going down to Norfolk, Virginia, Chesapeake, and the Navy's fuel storage farm on Craney Island, which is the biggest fuel storage facility, one of them in the world, and there's a lot of these systems down there, old systems. And now you know why I'm going down there. So we got to talk about how we're going to transition out of subsurface injection. There's a place called Kinder Morgan down there that actually I've got to go visit and talk to them about what the options are. Because if corporate says we're changing, I'm not too sure they thought about this. So alcohol-resistant variants were developed in the 1970s. I'm not going to spend a lot of time on this. All I can say is when the xanthan gum detects alcohol, it turns to a polymeric raft. So as the foam drains, as soon as you put it on the alcohol, a little bit of violence takes place and the foam blanket is destroyed for a moment. But what happens is this polymeric raft comes out underneath the foam blanket instead of water. It breaks the electrical connection between the alcohol and the water in the foam blanket. Alcohol has a tremendous magnetic attraction for water. So since the foam blanket is 97 parts water, as soon as you put the foam on the fuel, if it's not alcohol resistant, it disappears. So adding the xanthan gum changed all of that. So that was the big game changer here. And that's what it looks like after all the foam goes away. And that's isopropyl alcohol. That would be our test fuel. You know it as dry gas. The blue dry gas is methyl alcohol, the cheap stuff. The really good stuff was the red stuff, which is isopropyl, very aggressive. And that's what we use at UL for testing alcohol. So, alcohol-resistant foam. So that's what the goo looks like that I just pulled off the top of that dish after the foam went away. We sold the rights to 3M Company and others, allowing them to produce alcohol-type foam. So from a history perspective, you know the term ATC. Well, that would be their term for alcohol-type concentrate. The Ansell Company got in the game and we sold them rights to it. Their product became known as ARC, alcohol-resistant concentrate. And of course, ours continued to be the universal range of foams. Just to put it in perspective, that's why the names are the way they were. All of this changed in the last 20 years because the patents are all gone, so you can make the stuff in your bathtub. Alcohol-resistant fluorine-free ARF3s use a similar polymer. It's the polymer that does the work for alcohols, whether there's fluorine or not. The fluorosurfactants do nothing with alcohols. It's all about the polymer. So the new fluorine-free foams that have that polymer in it tend to be alcohol-resistant. I call them smart foams. They know what they're going on. If they go on hydrocarbons, they make a film. If they go on alcohol, they make a polymer. Add some more ethanol to this little dish here to bring its polarity back up. And now I'm going to
pump some regular AFFF into that dish. Let's see if we can zoom in.
AFFF or Class A foam or a wetting agent will do this.
This is straight AFFF. Also, wetting agents will behave the same way. And I'll just put that on there. And as fast as I apply the foam, the alcohol drinks the water right out of the foam blanket. Alcohol has a strong magnetic attraction for water, and that's what you're seeing going on here. The next thing I'm going to do is apply some alcohol-resistant foam. Now this would be Universal Gold, and this is a 3% solution, 97 parts water and 3 parts concentrate. And I'll just put a little bit on there to give you an indication that something is in fact happening. And what's going on now is the thick material that's in the foam concentrate is turning into a polymeric mass underneath the foam blanket. The foam blanket rides on the polymer, and that's what disconnects the alcohol from the water in the foam blanket. If I plunged it, it would destroy the foam, and that's just what I'm doing now, is I'm plunging it. Now the only thing left is the polymer. The polymer is the material that precipitates out of the foam blanket that allows the foam to ride on it. So alcohol-resistant foams, otherwise known as smart foams, will create a polymer on the fuel in case of alcohols, or in case of regular simple hydrocarbons like kerosene or aviation turbine fuel, and one can expect it just to make an aqueous film.
Not so anymore with the fluorine freeze. It won't make an aqueous film, but it will behave the same way on alcohol.
It's absolutely necessary that you apply the foam gently. You cannot plunge alcohol-resistant foam into alcohol. It has to go on gently.
So there's the xanthan. Like I say, if you look on the salad dressing container, you'll see that. You'll see it in other foodstuffs. There's nothing there that's going to give you babies with 3 heads. So there's sugar membrane is all that's left after 5 minutes. So reapply, because the membrane puts no fire out. That just breaks the electrical connection between the water and the alcohol. Vapor pressure. This is a thin alcohol-resistant foam blanket under pressure. This is at room temperature, 22 degrees C, 70 degrees F. And the bubbles that you see on the backside near the label of the container is where my fingers were when I set the glass down, where I set the dish down on the desk. Just the heat from my hand raised the vapor pressure at that spot that high. So be advised in combat that when you're dealing with some of these things, their vapor pressures tend to be very high. Their vapor pressures are adjusted with temperature. The higher the temperature, the higher the vapor pressure. You may play hell trying to get yourself proper readings with your detection equipment. If you smell the stuff, if you smell the fuel, you got a problem. You don't need a $10,000 gas detector to tell you that. The problem with that is your nose is up here and gasoline vapors are on the ground, unless the wind carries them up to your nose. So be careful of my comment about if you smell it, you might have to be crawling on the ground, but a good gas detector will find it. Yes, sir?
With E95, what's the burn rate? As far as, is it comparable to gasoline?
Negative. E95, which is 5% gasoline and 95% ethanol. We call this gasoline-grade ethanol. That's what's being shipped in rail cars. It has about a third of the energy. The ethanol fires are very approachable. Gasoline and diesel fuel and crude and those kind of guys have tremendous radiant heat. A lot of heat energy is being released. Ethanol is about, well, gasoline is approaching 20,000 BTUs of heat per pound, and ethanol is close to a little bit more than half of that. So this is why it's so approachable. No smoke. All right, it's going to burn with an orange flame. And the orange flame is the carbon fluorescing in the chemical chain reaction. So whenever you see orange flames, what you're looking at is the carbon fluorescing, whether it's on wood or oil. A lot of carbon, a lot of fluorescing. Low carbon, low fluorescing. So methyl alcohol, which is made from natural gas and other refinery streams, don't have carbon in them. So you can't see them during the day. At night you'll see a blue flame. Not a whole lot of carbon there. Ethyl alcohol is made from organic digestion materials, so there's some carbon in it. And that's why you can see an orange flame with your ethyl. And with the 5% gasoline that's mixed in with it, you'll see a smudge of smoke. There'll be a smudge of smoke. Now it's E98. The environmental folks have allowed them to ratchet down the amount of gasoline in it, so it'll only be 2%. Background story, cancer links. 1990s. Researchers identified 3M's long carbon chain electrochemical surfactant compounds, perfluorooctasulfonates, and the acid that it breaks into, PFOAs, used in aqueous film forming foams, AFFFs, to be bad actors. So they were identified as bad actors as far as health is concerned. These bioaccumulative toxic compounds have been detected in water wells near surfactant chemical manufacturing sites and military or civilian fire training facilities. 3M's electrochemical AFFF formulations were abandoned in 2002. They sold a license to the, I think, or DuPont, I don't know whether under license or not, made another similar product using the same electrochemical process, I understand. But anyway, the feds got involved at this point and said, no more. All right, so from that point on, non-bio-persistent materials were developed. But the term PFAS covers all of them. There's about 3,000 to 4,000 PFAS species out there in the world that have all manner of commercial and industrial applications. So when someone says no PFAS, it's a mouthful because that's going to affect a lot of things. So when they do the legislation, they have to be a little bit more specific about that, because if somebody just says PFAS, it's... And Maryland did it last year, and suddenly the governor saw it and said, I ain't signing that, because they were talking about the textile industry and everything in that state. So they're trying to pull the PFAS out of firefighting foam, fine. And other things, I don't have a horse in any of those races, so I'm not going to have an opinion. Replacement chemistry, used an 8-carbon chain C8 telomere-based fluorosurfactant that's said to be non-bioaccumulative but still environmentally persistent. They have proven as effective as the now obsolete electrochemical fluorosurfactants of the 20th century. So the industry-wide has changed to the C8, C6 fluorotelomere stuff that's not biopersistent, but it is environmentally persistent. Now, this is what some science says. So there doesn't seem to be a whole lot of agreement on this. 2015, all formulations, AFFF formulations, transitioned to from C8 to a C6 purified fluorotelomere surfactant compound. The U.S. Navy mil-spec F24385 AFFF changed to C6 fluorotelomere sometime earlier, and is now the standard in the fleet and FAA Part 139 airports. So they say that it's not biopersistent, but certainly environmentally persistent. So that's what I know right now. And here's a little bit of background. There's the fluorine, the fluorine guy up there. That's that element. And they connect a whole bunch of carbons to it. The longer the carbon chain, the more persistent it gets. Carbon makes it more and more bulletproof, as it were. PFAS, per and polyfluoroalkyl substance, is a catch-all acronym that encompasses most things relating to fluorosurfactants, which include AFFF, food contact, paper, textile coatings, All right, 2 compounds, I already said this, are said to be persistent, bioaccumulative, and toxic. Some long-chain film-forming chemistry, include PFAS and PFOA, is said to be cancer-linked and long-term environmentally persistent. It's no longer available in the United States and hasn't been for quite a while. 6-carbon chain chemistry has replaced the 8-carbon chain chemistry and is considered non-bioaccumulative. Check PFAS regulation status with your state environmental authorities, because I do this all over the country and everybody has a different rule. Some science suggests that there are trace amounts of bioaccumulative components in C6 chemistry, which is why all PFAS compounds, regardless of origin, are now being painted in some circles with a suspect brush. Regardless of the outcome of the science debate, there are those who would prefer to remove all fluorosurfactant PFAS compounds from firefighting foam. In fact, there are some states in the process of legislating the extinction of PFAS, AFFF firefighting foams, and is why green screen certified fluorine foam replacements are available. When I say green screen, I know that there's a third party saying it doesn't have it. Now, here's a disclaimer. When we say fluorine-free, we mean that we're not intentionally adding any fluorosurfactants, fluorine, when they manufacture the foam. You know, don't forget there's fluorine in the water that they mix it with at the factory. So when someone says it's fluorine-free, it's maybe not right. So what we're saying is there's no fluorosurfactants added. No intentionally added PFAS. And you'll see that disclaimer, if they're smart, all over. Because if someone says we're fluorine-free and you check it out and say, well, hell yeah, there's fluorine. It's in the water that they mixed it with. So now now we have to define what clean is. There's the 900-pound gorilla down in Connecticut right now. In fact, I'm stopping there tomorrow on my way to Maryland, or to Virginia. Oil and water do not mix, and here's the wetting agent mechanism. Actually, it's just detergents. Oil and water don't mix and are known to be insoluble since their electrical systems tend to be similar, plus plus. The addition of a detergent surfactant, plus minus, and a shake or energy mix creates a plus minus emulsion, which is the mechanism of dish soap or wetting agent fire products. Some foams, some do not. So you add it. Here's a solid cruet, and this is my example, water and oil. Tear open the package of good seasoned salad dressing mix and pour it in on top. Then what do you got to do? You got to shake it, because now what we have to do is align the pluses and the minuses. And you got to do that with energy. And that's why you got to shake it. This is why when you wash your hands, you have to do this. You got to align the pluses and the minuses with the detergent, water, and stuff you're trying to emulsify. This is why your washing machine has got a zhoo, 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 zhoo in it. Your dishwasher's got a zzz, zzz, zzz thing in it. It's got to have energy in order for detergents to do what they do. So once I got fuel on the ground and it soaked into the earth, the energy ain't an option anymore. It's only an option with my demonstration, and I'm guilty of it. So, that said, these are some of those products. And I'll paint myself with the same brush. And they all have NFPA 18 UL listings, not NFPA 11. The science is irrefutable. It's good science. It does what they say it'll do on most oils. Certainly not gasoline. And certainly not fuel soaked into the ground. That's just impossible. I'm not going to waste your time with that. Did that screw you up on your... You went right past? You are good, Paul. All right. Will airport foam MIL 24385 be affected? Not at the present. February 2020 is when I wrote this. The Federal Aviation Administration still mandates FAA-controlled airports use a C6 mil-spec foam. That would be Part 139 airports. There are some airports that are smaller airports that are not so regulated. However, FAA reauthorization legislation HR Bill 302 of October 2018 included wording that will allow airport fire departments to substitute MIL 24385 with a qualified by NFPA, check that, with an approved fluorine-free agent, qualified by NFPA 403, within 3 years of the Bill 302 becoming law, targeted for October 2021. So when I wrote this, my crystal ball hadn't gotten to where it is yet now. And right now, we're getting a little bit of a tap dance because they haven't made up their mind exactly yet. NFPA has not been on a tap dance. They've been on top of their game. NFPA 403 has recognized the new technologies. FAA hasn't yet. They probably will. Military is on its way to. FAA is still, they're going to do it. It's just, I think that PFAS has really laid them low in terms of R&D, and I suspect that that's what's going on there. What are ICAO, International Civil Aviation Organization, foam standards, and why should I care? Well, if you're one of those folks that are watching this on your computer or TV out there, you should care, because chances are you're going to be hearing ICAO a lot more as time goes forward. We're going to shift, or perhaps will be shifting or transitioning to their way of thinking rather than the U.S. Navy's mil-spec thinking. So let's talk about that briefly. Other than in the United States, firefighting foam products are regulated by International Civil Aviation Organization, ICAO, performance regulations, and may soon so be in the United States. In the U.S., NFPA 403 standard for aircraft rescue and firefighting is the ARF guidance document. NFPA does not approve or test fire foams, but rather promulgates performance standards which are currently set by FAA and certified under the U.S. Navy's AFFF specification 24385. So everybody's got the same stuff. Wonderful. When they start making this transition, everybody's not going to have the same stuff, and I'm wondering how that's going to work. ICAO have performance levels A, B, and C for fluorine-free foams, which differ from mil-spec AFFF and are now recognized by NFPA 403. NFPA said, okay, we're going to recognize ICAO now. And I know they did a lot of research. The people on that committee, I take my hat off to. ICAO performance level C is equal to MIL 24385 in terms of its application rate. Levels A and B are not, and require more water and concentrate storage on ARF rigs to be A-B compliant. So if I have a Jimmy Cottrell ARF truck that's 2020, that was made in 2019, just delivered, I'm operating with mil-spec 24385 in a foam turret and a foam proportioning system designed to work with that stuff. The application rate for mil-spec AFFF for Part 139 airports is 0.13 gallons per minute of foam solution per square foot. It's about 30% more than my rule of 10 number. The Navy ain't in a crapshoot, excuse my expression. Out in combat, they probably know that they can probably do it at a tenth. Their spec says 0.13, a little bit rich. That's just my guess. So somebody had to invent a fluorine-free foam that you could apply at a 0.13 to get the ICAO level B as you were, ICAO level C. ICAO level C is 0.13. So the good news is that Jimmy Cottrell crash truck that was just delivered, if I put the ICAO level C foam in its tank, I'm good to go. I may have to change the way the turret aerates or what have you, but they're going to be very discrete changes. I'm not going to have 20% more water and 20% more concentrate on the rig, which means re-engineering and buy a new rig. Over in Heathrow and some of the European airports and UK, their rigs are a little bit bigger because there was no such thing as ICAO level C when the Europeans, who are way ahead of us on this, started changing and transitioning into fluorine-free. So the fluorine-free ICAO spec A and B are yesterday's technology. ICAO level C is very, very difficult to do. It almost has to be a film-forming fluorine-free foam, which is a really tough bridge to cross to get past that performance specification. At this point in time, it's not clear what firefighting performance standard FAA will adopt. Now, that's when I wrote this back in 2020. Fluorine-free, non-intentionally added, we've got that. U.S. mil-spec versus F3. It's pretty much a foregone conclusion that the U.S. mil-spec AFFF is the world gold standard in terms of ARF users, all right? Safety and passenger survivability kind of relies on that. Not many fluorine-free foams can match its speed of fire knockdown and security, although there is one, which is a film former that matches the U.S. mil-spec application rates. If the U.S. mil-spec AFFF is abandoned, ICAO performance level C fluorine-free foams are, at the time of this writing, as good as it gets in terms of firefighting performance, with application rates equal to MIL 24385 of 0.13 gallons per minute per square foot. So the good news is it's there. We've crossed the bridge. ICAO performance level A and B foams are not as effective as ICAO level C in terms of application rate and how it bears on concentrate and water carried on an ARF unit. You understand that now? If I got A or B, I'm going to have to put more water and concentrate on the rig. If I've already engineered for a 0.13 application rate and I just took delivery of the truck that has a 0.13, I got a drop-in replacement now. Background program, what's Mass doing? I was kind of hoping Nick would be here to take over at this point for a while to start giving you his perspective and the Commonwealth's perspective in terms of the environmental issues. Actually, truth be known, I invited Nick to come and speak in New Jersey 3 years ago because Massachusetts was way ahead of the curve. And I really wanted people to talk to him. He was kind enough to come down and, on his time and speak to FDNY and the New York State people and people from Maryland and Delaware. So I was tickled that he could be there, and he's a great public speaker, as you know. So he gets it, and check with him is all I can tell you right now, where the state of the art is as far as the Commonwealth is concerned. Foam application rates. F3 should be used with aerating nozzles or attachments at a minimum of 5 to 10 to 1 expansion on hydrocarbons. 5 to 1, we're just barely getting through the test. At 4 to 1, I can't pass the tests. No matter what, no matter how hard, no matter how I hold my tongue, and I just can't. We struggle to get through it in 3 minutes. 3 minutes is the time for this 50 square foot test at a rate that's 40% less than what we put on the container. So if the container says 0.10, I got to pass the test at 0.6. All right, that's the UL's Murphy factor built into everything. All right, so when you're using a 0.13, actually it's 40% less than that. All right, to get through the test. And I couldn't get there with a 4 to 1 expansion. And if I did, my burn back resistance was terrible. I mean, if I brought the torch back after about 2 minutes, it lit back up again. And this was heptane. And heptane is nothing like gasoline, to my way of thinking. So here we are at a low expansion, 7.5 to 1 thereabouts, with that old Angus foam tube. Now this was back in the 80s when I was a kid. Well, not quite a kid, but anyway. And then we went to, some of you may know that my fingerprints are all over the TFT products because as a contractor I helped them with their foam stuff. So that's why we invented the medium expansion thing there. So this would be a 25 to 1 expansion at 125 gallons a minute. So we got a little bit more water weight working for us there. So the vapor suppression with medium expansion foams up to about 25 to 1 is optimal. Putting the fires out 7 to 10 to 1, and if I had my way, I'd be 10 to 1 all the time. The better the expansion, the faster the fire is going to go out and the more secure it's going to be. Yes, sir?
Do you lose significant throw?
Oh, hell yes.
1 to 25 to 1?
With this one on the right, as I increase my, the one on the right, if you turn it all the way towards straight stream, you got a jet of foam, a rope, that expands about 7 or 8 to 1. As you go from straight stream towards fog, you're entraining more air, and you're hitting a screen that's in the middle of the nozzle. The screen makes sure all the bubbles are the same size. That was a pretty neat invention. We thought about that back with Dow Chemical and DuPont when we were trying to deal with their fuming chemicals in the 80s. So I just cross-pollinated that into this thing. And so as you go from straight stream to fog, you change your expansion ratio. Your reach changes proportionately. So as you go from straight stream with a 100-gallon-a-minute stream, you're looking at about 70-ish feet, give or take. And as you go from straight stream towards fog, it drops off proportionally until it's just falling out of the thing. So it's definitely not for firefighting. It's for post-fire security, vapor suppression. If you want firefight, go all the way to straight stream and get that reach. And as you want to do vapor suppression, now you have the tool all in one. I think Elkhart now has something like it as well. It's pretty cool. I have no horse in the race anymore. I've retired out of that company for 5 years now. Full disclosure, my son's running it now, what I used to do. So, liquid fires are fought by the square foot. Determining finished foam application rate is much like house painting. You need to know how many square feet of wall or floor you need to cover before buying the paint. Subtraction of the fluorinated surfactant PFAS compounds from AFFF foam require firefighters to use aerating nozzles or attachments on most fuels. We prefer it to be up with anything from 5 to 1 up. To my way of thinking, a little bit better than 5 to 1 is good. Training tip. Liquid fires should be treated with F3 foams as if they were polar solvents. And I know there are some people in the audience already that I don't need to tell this to, they can teach this subject. The smart money from management's perspective would be to tell the troops, if you've already taught them how to deal with alcohol, to tell them to treat all fuels as if they were alcohol. If you can cover that bridge, you've got it made. All right, so if you have an alcohol-resistant, fluorine-free, and there's several of them out there, make sure that you just tell the troops to make believe all hydrocarbon fuels are also polar solvents. That way you will apply gently, and you'll have a good aeration going for you, because you had to do that with alcohol. Alcohol-resistant formulations, ARF3s, are available using similar non-fluorinated polymers as found in AFFFs. I covered that already. UL application rates for spill firefighting can increase by as much as 60%, I already said that, and stay the same for fuel storage tanks. So the guys in the oil patch, if they have to make the transition to fluorine-free, they're already there because they had to go to 0.16 for over-the-top firefighting with AFFF in many cases. Fluorine-free foams are not intentionally added fluorine-free compounds. The rule of 10 for AFFF and the rule of 4, I think I covered this earlier in my, the way I teach doesn't necessarily mean I follow my own rules. So here's the rule book. Multiply the 60-gallon-minute deductor times 10, and you'll have a 600 square foot success. With fluorine freeze, multiply times 4. So if you remember my old rule of 10, and I do know there's people here that remember that well, just replace the rule of 10 with the rule of 4, and you're good to go. So here's something that I'm thinking about now, and I've been thinking about it for months. I'll share it. Since we know that the application rates have increased by a lot, right? I'm going to say that the 60-gallon-minute deductor is a dinosaur. The 95-gallon-minute deductor is a dinosaur. 125 deductor is probably minimum. now, which may make management have to buy something that would that they probably might not. But to my way of thinking, I want proportioning accuracy spot on. Remember, the fluorine is gone. So all the stuff that made us look good is gone. So we got to manage these things a little bit better. And we're assuming that 125 gallon minute deductor is drinking 7.2 gallons of concentrate a minute, 3%. Who said? Where's that written? Is it a UL listed device? Hell no. 3M and, I mean, National Foam and, oh well, National Foam does, but the mainstream guys, Akron, Elkhart, TFT, who else did I miss there that I'll piss off if I don't mention their name? Anyway, Kochek, I think they got some imported nozzle or something. Foam eductors are funny things because you want to make sure you're proportion accurate. When I say 3%, that means 97 parts water, 3 parts concentrate at 7 to 10 to 1. How do you know you're proportioning accurately? When you had the fluorine in the foam, I was kind of like, we'll be all right. Not now. You got to make sure that you're proportioning accurately. There's ways of testing it. Contact me. I'll give you the recipe of testing it, because I had to do it for FDNY, and they got over 300 foam eductors. They threw all of their foam proportioning systems under the bus. They're just using simple foam eductors now and loving it.
What GPM are they using?
125s. 125s. And if I could make a 150, and my fingerprints are on a lot of this stuff, I would, but now I got a problem with 1 3/4 hose. At 150 gallons a minute, the distance between the nozzle and the eductor starts to really get low. If I can talk the fire service into using 2-inch hose with 150 gallon a minute or 175 gallon a minute eductor, then you're back in the game. 2-inch hose has half the friction loss of 1 3/4. That way the distance between the nozzle and the eductor changes proportionately. I'm not going to get into all of that with you now. This is not part of that, but there's a handout on the website that explains it. The 250 eductor will now cover 1,000 square foot. Used to cover 250 at 2,500. And if you have one of those 350 gallon minute eductors for your blitz fire, it went from, whatever. It went from that to that. Let me go back. Might help. I did it again. What a schmuck. Whoops. Okay, everybody knows it now. Right, the 350 eductor will cover, used to do a 3,500 square foot spill, which is a really sporty size fire. If you think about it, a single family frame has about 800 to 1,000 square foot on the first floor, thereabouts. The old Cape Cods had about 700-800 square feet on the first floor. So when you take a look at that without furniture and everything, that's a big sporty fire. Here's the problem. Reach. If I got a 700 square foot fire and I use a 100 gallon a minute eductor and nozzle, I'm not reaching it. There is the problem. And I've run into this. I got a program called Combat Engineering that gets into all of this. But sometimes you got to use the 250 gallon minute nozzle and eductor to reach the fire that you've calculated you only need 100 gallons a minute for. So reach and range is my pet peeve. Anybody that's sat through my combat engineering programs will know that that's all I preach, is reach and range. Polar solvents, alcohols, esters, and ketones. The most likely fuel firefighters will encounter are transportation events where gasoline-grade ethanol or methanol is in transit. UN placarded 1987. Most UL-listed ARAFFFs, this is the old technology, will apply aerated type 2, gently, at 1/10 to 1/4 of a gallon per minute per square foot, depending upon the solvent involved. Solvents have different magnetic strength. The more polar they are, the more attraction they have for water, the higher your application rate has to be. you have to have a higher application rate to accommodate the polarity. On ethanol or methanol, some AR-AFFFs will apply type 2, remember gently, at a 0.10 gallons per minute, and as high as 0.3, 3 times more, for the most aggressive solvents. Refer to your manufacturer's data sheet or their UL listings for application rate guidance. So whatever you do, you're going to have to make reference to what application rates have to be. I can tell you that ethanol and methanol are likely to be the two that you're always going to run into out there on the highway, and they are day on the beach. They're easy. That would be a 0.10, at least for my stuff. I mean, it's easy. Once you get up into the isopropyl alcohol, ooh, that's a different story. You really have to have your act together. So if you're hazmat guys, and say you got a foam trailer that's the hazmat asset for a certain county, that's the one that has to have a long pedigree of UL listings. Because it's likely to be invited, more likely to an unignited event anyway, because by the time they get it there, most of it's over. But if it's unignited and you're babysitting a big event, you're going to want something that'll hold up long-term vapor suppression with as little environmental impact as possible. No application rate for unignited polar solvents. Maintain a minimum 4-inch foam blanket. Replace as instruments indicate or as solvent odor returns. Somebody held my feet to the fire on Thursday in New Jersey, because we do this program and then go outside and actually do it. And they said, show me what a 4-inch foam blanket looks like on the ground. Got me. Gravity's wants to keep pulling it apart. All right, I got it maybe to 3, and then I cheated and I got to medium expansion, then so, now you just heard me take the hit. They caught me. Actually, it was the FDNY hazmat guy said, well, yeah, you're saying 4-inch, how do you get 4 inches? Well, we were there doing it. I said, there's a 4-inch. No, it isn't. Close, but not 4 inches. So I also throw darts at the wall when I'm speaking. 3% AR F3 UL application rates. Application rate is foam water solution flow per square foot of fire. 1,000 square foot gasoline hydrocarbon fire requires 160 gallons a minute to achieve extinguishment. That would be a 0.16. That would be for the UL application rate. Well, I'm going to blow through this one because I've already burned them out with this application rate stuff. This is what a UL test pan looks like. This is what I did in Jersey Wednesday and Thursday and Friday. We had people from all over the East come to this. And what we had to do is put the fires out in accordance with its UL listing. So I did the wetting agents. Couldn't put any of the fires out with the wetting agents because I didn't have a water bottom in them. I put gasoline in the pan with no water in the bottom. That was the end of that. It was Katie bar to door. Couldn't put the fire out. Some of the other foams worked fine, some didn't. But that would be what that looks like. It's 50 square feet. So if you apply the 1/10 of a gallon per minute per square foot thing, that would be 5 gallons a minute. You got to put the fire out in less than 3 minutes with 5 gallons a minute and hold for 15 minutes after you put it out, which makes it kind of difficult. So I'm not going to bug you with that. This is on the handout. If you want to read it and you want to do research of your own, that's fine. I'm not going to spend a lot of time on that now because I see I'm getting close to the 12. Marine. This is one of my specialties. So the marine stuff is going to be tough. Making the calls for marine. Massport has a really nice boat. Boston's got a nice boat. There's a couple of others along the waterways that have foam systems on board. Now we're going to have to aerate. The good old aqueous filming is gone. So we've pulled a lot of the fangs out of the snake now by eliminating aqueous film. And this guy's got, the guy in the middle there, actually the other day I had to deal with it. So anyway, the systems have to be accurately proportioning now. Just no question about it. You've got to be, I'm fine if it's 1 full % rich. In fact, UL says you can be 1% rich, but you can be no lean. Okay? So that's my rule of thumb when I go out and do these tests. Somebody says it seems to be a little rich. Well, if it's 1% rich, I'm good. Can't be more than 1%, then it gets to be stupid. But no lean. Here's my F3 discussion. I got a fire on the water here in Virginia. Come on, you damn fool. And this fire self-extinguished, believe it or not. This was back in crude that came off the rails along the James River, which was pretty cold. And as the back in crude spread across the cold river, thank God for the fire department there, it struggled and went out. If it didn't, well, wouldn't have made much difference because it was in the river heading downstream. So polar fuels, alcohols, esters, and ketones will disperse in a water column, usually diluting enough to save the fuel. Large spills such as derailed tank cars, barges, or seagoing vessels may see fire at the point of insult. That means where the hole is. As fuel-water ratio at or near the breach will support a fire. In this case, aerated alcohol-resistant foams are indicated. So even if it's alcohol, that's a shipload of alcohol pouring into the ocean. At the point where it's pouring in, the alcohol is in fact going into the water column and dispersing, and ethanol at about a 4.5 to 1 dilute will go out. But while it's pouring in, the area immediately around that hole is very, very rich and keeps burning. So just having, when someone says, well, it's only alcohol, don't worry about it. Well, if it's gasoline-grade alcohol, you're going to have a problem. Gasoline-grade ethanol, E95 or E98, contains from 2 to 5% gasoline. 1,000 barrels, see, we measure now in barrels, not gallons. There's 42 gallons in a barrel. All right, so 1,000-barrel gasoline-grade spill, which is a small one, we'll see as much as 2,100 gallons of gasoline floating on the water. So if the tide's running out, good. If the tide's running in under the docks, now you got a problem. If the wind is blowing it, you got a problem. Gasoline ethanol blends E10 are not likely to be encountered in maritime spills. E0 gasoline, diesel, jet, and bunker oil are the most common in your maritime fires. Propulsion fuel or cargo deck fires, dock transfers, machinery spaces, or bilges will need to be treated with the appropriate agent. It's not clear where the U.S. Coast Guard will go in terms of F3 foams going forward. Although my strong recommendation is for a universal ARF3, having the broadest range of UL Type 3 listings or U.S. Coast Guard approval. Coast Guard's a difficult approval to get for polar solvents. For the hydrocarbons, it's not that bad, but they're worse than the Navy. So this is what a fairly good, this is about a 5 to 1 expansion from the Bravest. This is at 2,000 gallons a minute, and he's got a pretty good froth going there. So if I had a gasoline spill, I feel pretty good that it'd probably knock it down. The trouble is holding it from another ignition is the problem. There is a big problem. So we're going to have to figure out how to put an aerator on that nozzle. And right now, that's something that I'm working on. It's hard to beat AFFF for fires on water, although aerated F3 foams are capable now. Most F3s have UL seawater listings. Be careful of that one. So if you're buying a fluorine-free or a wetting agent, you want to have assurance that you got fresh, brackish, and seawater approval. If I'm using brackish water, I'm in some of your waterways in these parts, or brackish for quite a ways up from the ocean, that will affect your quarter life or your residence time by as much as 50%. So foam quality is really affected by the salinity of the water. So what we have to do is jump through the UL hoops with seawater. And that was one of those scope document things. because most of the people that I deal with are are on the coast, no matter where I go in the country. Out in Oklahoma, they could care less. But here in New England, it's a big deal. It says break. I'm going to blow through the break because it's 11:30 and we'll get you out of here at lunchtime. Is that all right? What's that mean? 2-minute break? No? Two?
We're supposed to go 2 hours.
Well, I start. Oh, I am late. Way late. Okay. Water weight in the blanket is what holds vapors in check. As water foam drains solution, the blanket gets lighter, eventually allowing ignitable vapors to escape. When the blanket drains 25% of its water weight, I already said this, so I'm not going to bore you with that. Did we talk about this? We did. Pulling the fluorine from AFFF dramatically improved residence time. We said that already. Here's the recipe on how to test your own quarter life. Don't take my word for it. Just do your own test. Not very scientific as far as our science people are concerned, but they can't find anything technically wrong with it. So there's the recipe on how to do it. It's part of the handout. And now you can find out what your quarter life is. Now, quarter life is affected by the temperature of the fuel. So if you just put a really, really hot fuel fire out and there's a whole lot of radiant heat coming from wreckage and steel, you might not get your 2 hours. Hell, you might be lucky if you got a half hour. The quarter life that I'm referring to is at 70 degrees using fresh water. And you can do all manner of testing with it this way. Just to give you an idea of what it costs, I'm not going to give you that. You've got that. It's on the handout. Hell, look it up for yourself. This would be the economics, which is definitely an issue for a lot of folks sitting in the room. Use and storage. You can train with it with no fluorine complications. Warning, spilled foam concentrate is a serious slip and fall hazard. Can double as a Class A wetter at 0.5 to 1%. So yes, you can use it for Class A. Will you get a lot of bubbles? Not at 1%, not at 0.5%, but it'll soak like the dickens. Freeze thaw stable, may or may not be. Check the manufacturer's data sheet. That's a serious issue in these latitudes. 25-year shelf life in sealed factory packaging can be expected of all manufacturers. It's not a brand thing. Prevent evaporation stored if it were latex paint. Whew. So why didn't I get a high sun 2 hours ago, an hour ago? Thank you for your attention, ladies and gentlemen. That pretty much concludes the mass, as it were. If you want to do more of this stuff, Paul knows my number. We'll do more of it, and we'll. If you want to do the UL stuff, we can do it here. Yes, sir.
As far as the F3, still the same things with the inductors, 200 PSI, 200 feet?
Nothing has changed mechanically. What my view is most, all but the ones that I kind of invented for TFT, which are a new design, probably don't do alcohol-resistant foams very accurately. They were never engineered. They were engineered long before there was such a thing as alcohol-resistant foams. So my life's experience is that they tend to proportion lean, which was okay. I didn't really worry about it while it was fluorine. Now that the fluorine is gone, now I got to be a little bit more circumspect about giving people a pass on proportioning accuracy. So FDNY has just jumped all over me about checking all the proportioning accuracy on some of theirs. And we're going to do it. They're not in a crapshoot anymore, as you can imagine. So anything else? How about from out there in Paul land? They all went home already, right?
No, they're still here.
Oh, well, thank you for being there. Thank you for putting up with me. And after, I don't know when we're going to shut the video off or whatever, but I'm ready for questions. Hell, I'm ready for lunch. Okay, thank you again. Thank you.